So now we're doing part B. Now we're doing part B. And part B asks, what is the velocity of this object going to be, which has a 6 kilograms. All right, so what's the speed of the object at 20 meters? That's where we were when we found the energy. So we know it's 6 kilograms, and based on that, it'll be simple enough for us to find. There we go. All right, we know that work is equal to change in kinetic energy is equal to kinetic energy final minus kinetic energy initial, but we know the kinetic energy initial is 0. That's where it starts. So work is equal to kinetic energy final. Work is also equal to, actually, what we should say is kinetic energy is equal to 1 half mv squared, right? Kinetic energy final is equal to 1 half mv final squared. So that is going to be equal to, right. So the two equations we're using is R. There we go. How's that? Okay? Missed. All right, so 1 half mv final squared is equal to work. That means that velocity final is going to be equal to the square root of 2 times work over mass. That's just one that you will be familiar with the more you practice. So the square root of 300 joules over mass of 6 kilograms. All right, so V final is equal to the square root of 50, what are joules divided by kilograms? Dimensionally. Kilogram meters per second squared divided by kilograms, meters squared per second squared, right? And that's what we should get, because when we take the square root of that, we'll end up with a velocity. Square root of 50, 7 point something very small. 7 point what? Come on, somebody. Square root of 50? 7 point what?
0.07.
50 divided square root of 50. 7.07. 7.0. But that's the square root of 2 over 2. That's kind of weird.
Okay.
Is it 7.071?
Yeah, 106.
Wow. I got to figure out why that's true. All right. But anyway, that is right. That's right. That's 10 times the cosine of 45, right?
I just saw what you were talking about.
All right. That's it. 7.07.